Right, this is a little video about radians, specifically for those that missed it this morning, or if you just want to have a look at it again. Okay, so a radian is another way of measuring angles. The first thing to note is your calculator can get into radian mode. So if I turn my calculator on and I go into Shift menu, go into Setup, you'll notice the second one down there says Angle Input, or Angle Unit, should we say. If I press Angle Unit, it gives me three options: degrees, radians, and gradient. Now, degrees are what you're used to, but now we're going to be learning about something called radians. Radians will be a little R at the top of your calculator. So where you used to see a D at GCSE, when you need radians, you need to see an R. Now, firstly, what is a radian? Well, a radian, as we said, is a measure of an angle. Now, normally we know that in a full revolution there are 360 degrees. Well, 360 degrees is equivalent to 2 pi radians. That's the symbol for radians. It's kind of like half a degree sign. So 360 degrees is worth 2 pi radians. That means that 180 degrees is worth pi radians. 90 degrees would be pi over 2 radians. Of course, if you prefer, you could write that as a half pi. Entirely up to you. 45 degrees would be half of that again, so it would be pi over 4 radians. Then the other two that you meet relatively often are 30 degrees. 30 degrees is pi over 6, and 60 degrees, which is pi over 3. These are worth learning off by heart, because sometimes you're going to be too lazy to turn your calculator into the right mode, and then if you know which angle it is, you can just use degrees. Right, so those are the ones that are the most useful for you to learn off by heart. So when do we use this? Well, we use radians in 3 different scenarios. Scenario number 1 is all the questions that you did in year 1 on trig can be done in radians too. So normally we would be solving something like cos x equals 0.4, and they would tell you that x lies between 0 and 360 degrees. Well, you know it's in radians if instead of them saying 360 degrees, they write 2 pi. Right, let's quickly recap how to do this. So the first thing you would do is you would do cos to the minus 1 of 0.4 onto your calculator. Now remember, my calculator is now in radian mode. So I go shift cos 0.4 and I come up with 1.159. Now, if this was in degrees, you should be screaming at the screen going, that doesn't make any sense, since when is an angle so small? Well, that's because it's in radians. Now, we remember that in the cast diagram, cos sits here. Cos is 360 minus. Well, we're not in degrees, so we can't use 360 minus. So instead, we do 2 pi minus. And 2 pi minus 1.159, or if you've got your calculator still handy, 2 pi minus answer, much more accurate, gives me 5.12 radians. And there I have my 2 answers. So all those lovely questions when solving trig equations that you learned to do in first year, you can now do with radians as well. And I think I gave you a worksheet at one point which had radians stuck in, and we were a bit confused about what they were doing there. Okay, now the other most powerful thing we can do in radians is all about areas of sectors and length of arc. So a quick reminder, if I have a circle and I have 2 radii and they are subtended by an angle theta in the middle, this area between those 2 radii is called a sector, and the length that goes from one section to the other section here. Oh, that should have been a different colour. Sorry about that. That little section there should be an arc. So at GCSE, you learned how to do this. If you remember, to find the area, we know it's pi times radius squared. But because it's not a full circle, we do theta divided by 360, because that's how much the degrees are, times pi times r squared. Well, if we're in radians, that 360 degrees becomes 2 pi. The pi's then now cancel, and I come up with the first of my formulae, which is that the area is a half r squared theta. There's the half, there's the r squared, there's the theta. And that is the area of a sector. Notice, if you're using this formula, that angle better be in radians. It does not work for degrees. Degrees, you'd put that 360 there, and it would be completely different. Okay? Then, length of an arc. Well, an arc forms part of the circumference. So if you remember rightly, circumference is pi times diameter. Now, pi times diameter is not very useful. So instead of diameter, we're going to use 2 radii. Once again, we'd have the angle out of 360 times by pi times by 2r. Instead of the 360, we want to be in radians. I'm going to put a 2 pi. Look what happens now. Pi cancels with pi. 2 cancels with 2. And I get the length of an arc is equal to r times theta. And that is the second formula that we've got. The length of an arc is r times theta. And we can use those in questions to be able to work out the length of an arc and the area of a sector.